Hi there, welcome back to Mr. Elko in the Math tab. Today we're going to go over really briefly how to calculate a trig ratio based on a triangle. Now we have two examples we're going to do here. One of them has all three sides filled in and one only has two. So we're going to briefly go over how can we use our SOHCAHTOA ratios in order to solve or create a ratio that we want to look for. So first thing we're going to do is we're going to take our first triangle here, and because it has all three sides, we can actually select any of these options. So a quick little example here. So if we go over our ratios again, we'll know that sine of whatever the angle is that we're looking for, that's where that theta value is, equals opposite over hypotenuse, O over H. Okay? So if we start with our angle, my opposite would be here, my adjacent would be here, and my hypotenuse would be here. And then I just fill in my values. So if it was opposite over adjacent, I have opposite, I have hypotenuse, so I would have 4 over 5, or a value of 0.8. If I did cosine, which is adjacent over hypotenuse, I plug in my values. I have my adjacent value, my hypotenuse value, and I get a value of 0.6. Tan is opposite and adjacent. Over 3, and we end up with 1.3 repeated as our ratio values. Now, how we're doing this is, this just gives us our ratio. That's all this tells us. This just tells us our comparison between these two lines to each other. So sine is accounting for the opposite distance compared to our hypotenuse distance. Now, if we move over to this example, right? I have my angle theta up here, the angle that I don't know, the one that I'm going to be looking for, but I'm looking for the ratio. I'm not looking for degrees or anything like that. I'm just looking for the ratio. But because this value is unknown, it's blank, I'm unable to use any of my ratios that involve the opposite point, which means sine cannot be used and tan cannot be used, because I need to have both of these values in order to create that ratio. So as a result, I'm forced to use my cosine ratio. So then I would go over here, I would write cosine of my angle theta is adjacent over hypotenuse. I would find where my adjacent angle is, so in this case 8. My hypotenuse angle is always across from my 90-degree angle, so I would fill it in. 8 over 10. I could divide it out, and I would get a ratio of 0.8. So there we go. Now, if we're looking to find the angle, this is where things are going to change a little bit. So I'm going to keep my ratios here. Okay, I'm just going to fill them in here briefly, and I'm going to show you how do we go from our ratio back. Now, I don't have a calculator, so I won't be doing the full process, but I'll fill in the gaps where we can. So all we're going to do is sine theta that we figured out it was 0.8. So what we do is we need to get this theta by itself. So what we're going to do is we're actually going to divide by sine, which means these will cancel out, and I'll be left with theta equals, so I'll kind of get rid of those, 0.8 divided by sine. Now we don't write it that way. What we do though is we use our inverse reaction we can find on our calculator, and it looks like this. Sine of -1, 0.8. And when we plug that into our calculator, that will give us our degree angles. And it works for all of them. So these ones, for example, would end up being, so this one was 0.6. We would divide by cos. These would cancel, and this would equal cos of -1, 0.6, and we would get everything. So, hope this helps. Thanks for joining me. I'll see you next time on Mr. Elko in the Math Tub. Take care.